Welcome back to our tutorial on how to construct a helical gear. So today we start with the um, function of generative shape design and the shape, and we name our part file as helical gear 3721, sorry, 722, 720. Okay, now we are in mode, so we can start our um, sketching by firstly inserting a geometrical set, and here we can name it as wireform, and from this wireform we create 5 circles, and from these circles we create the origin at 000. Click OK, and the support will be the YZ plane, and click on the complete circle, and the radius we change to diameter, and this diameter is according to our calculation. So we start with the outer circle, 73.5 millimeter. Click OK. Then we continue creating the other 4 circles. Again, the origin is our center point, YZ plane is the support plane, and next will be the diameter of this circle. So the next circle point, YZ plane, and then the next one is this, the fourth one, YZ plane, 69.999. So these numbers are all calculated by the given equations in our project instruction. And lastly, 70.5 will be our curve. Alright, so here we can rename it to for us to identify which one is which one. So this one is the outer curve. We can name it as OC. Next, second one this is the CP. So we can enter CP. The third one is BC. Base circle RC. And the last one will be PCD, for the pitch circle diameter. So we name as PCD. Okay, after we have renamed all the circles, what we need to do now is to create a point, and this point has a coordinate of 0, 0, 20. So at Z, click OK, and then for each circle after this, we need to do an intersection with the point that we have created here, 0, 0, 20, and this is in order to create a reference point for the points that we will create on the curves for each curve. So we click on this intersection function, and then okay, sorry, we can click all the circles, 3, 4, 5, close, and the second element will be X plane, and then click OK. Now we click on keep only one sub element using a near or far, OK, and then reference element will be this point, click OK. We need to repeat this for the next 4, 5 times. because we need to complete all the circles. And again, and lastly this one. Alright, so we have created all the section points with this reference point here. And with this reference point now, we need to create new points on each of the lines that we have. So we start with the outer circle here, 777, 0.577, like this. And other parameter is the same as it is. Extrude will be this point. Then you click preview to look at our content. Then click OK. Right, so for the next one, PCD, the same again, we need to choose this, and the length will be 1.178 for PCD. Click OK, and for this line, CP, so this one, CP, the value is this. Click OK, and lastly RC. So we don't need the other one. This one is what? BC, base circle. So we need the RC, and with the circle the point there, and the last will be 1.58 length. Click OK. So from here we need to create spline. Click OK. To enter the sketch, and you click on the YZ plane. So we need to create a sketch that combine this line, this point, up to this line. So go up here and go click the vertical line there, and you go back here. You can click this point and click this point. You can then create a coincidence. So we then created a vertical line linking the spline that we have there. Okay, now we have to exit the sketch. And with this, now we can connect these two, join these two, and then click OK. So we have a new join there, join line. So we need to create a corner, and this corner should be corner function. Okay, so firstly we need to take this one, and then the next line is this one, this line, and then we need to select the solution here, and the radius would be 0.1 times module. So module is 1.5 view. So we click OK. Right, so need to trim element 1 and click OK. Right, so okay, next we need to combine this line. Just now we had this and we had this, and then click OK. what we need to do is um, we go to insert by clicking on the line that we have created just now, the spline that we have created. Go to insert, go to analysis and porcupine curvature analysis radius. We have this result that shows that our connection is consistent. So just click OK. Right. Next, what we need to do is just this one can be hidden. We need to select the corner, the line and the spline that we have, and click join. Okay, so we have the second join now, and with the second join here, we need to mirror it. So click on mirror. Where is mirror? This is mirroring. So we click on symmetrical. Exact plane. So we click OK, and we have our first complete tooth sketch. We need to join these two. So we have our third join of our sketch waveform, and next we need to trim the this one, the base circle, against this tooth sketch. So we need to create split definition, and the first definition would be the circle, and the selection would be our joint 3, and then we need to create we need to make sure that this one is now orange. So we clicking on other side so that we have that yeah, the split. Now with this split, this PC should be reshow, and now we have the split and the join. Split and join must be connected back. We have this join that represent our tooth shape of our sketch. Right, now with that finished, we can close the waveform, and now we can create a new geometrical set, and here we name it as surface. So now we now in the step of creating a surface form. Alright, so now what we need to do is okay, we need to extrude the base circle. So this will be our first form surface from the diameter that we have created just now. We need to create extrude. So, and the extrude is direction in x axis. So the dimension of extrusion limit should be checked back with our instruction name. So we have 20 millimeter. Okay, so we have 20 here, and then click OK. Okay, now we have the complete form of our wire tooth. So we change the side here, and we need to create the line that connects this point to this end line at this edge. So this time we need to create a line directly on the generative shape design, not in sketch. And this line should have an inclination angle of 95 degree according to our instruction. And here in line type, we change to angle normal to curve, and the first curve start with the base circle, and the support will be this extrude one. and the point that to be selected is this point, and the angle is 95 degree. um, so the up to 1 and up to 2 is this line now. We need to create geometry and support, and then click OK. Look at the front. Yeah, the front view, we have the line that is inclined to 5 degree. Okay. Okay, now we need to create a sweep, and this is done by clicking on sweep. So the first element to be selected will be okay, this one, 0.4. Guide curve would be this line, and surface will be this extrude one. Angle 0, remove cutters onto view, disable fill twisted area and compute zero vertices, and standard tool, and click OK. So we have created the gear tooth surface that covers the profile of the tooth on top of the extrude surface of this base circle. Okay, now we come back to wireform, defining work object, and now we need to close the surfaces that is left behind, and here we need to click on sweep, and then click on boundary, click on the surface here, click on OK, click on only. Now we select far, and reference point will be this point. Click OK. So we have that, no? Oh, so the one that is selected for our far point will be this point, reference element. Okay. Then we change back to surface work object, and then we need to complete the surface by using fill function, and click on this, then OK, and the same goes for the other end. Then click on this fill and click on this surface, and here we have the closed surfaces of our gear tooth. Alright, so now we have all the sweep, fill 1 and fill 2 element, and what we need to do now is to join all these three. Click OK, so we have joined 5 that represent the tooth of our gear. Right, so from here we need to just change back to pad. Up until here we have finished creating the wireform and also the surface form of our Helical Gear. So we can also save it. So here we can save our CAD part, and for the next step we need to change the environment to mechanical design, part design, and here now we can start padding. For that we need to define part body in work object, and then we click on um, pad dimension. um, the length would be the um, width of our gearbox. It's of our base circle, which is 20 millimeter, and the selection would be our base circle, and should be in this direction. So we have created our base circle, and then we need to fill in our close surface, our tooth here, by selecting the joint 5. Okay, and then we can hide all the surfaces that we want. This one is waveform, so we go to surfaces, we can hide this, and even this extrude can also be hidden. Yeah. So now we need to multiply our tooth here, and by using this circular pattern, I choose the complete crown parameter, and the instances should be copied from here, 47. So this is also given in the construction sheet, can be calculated by equation, and the reference element would be x-axis, and yeah, the current solid is already selected, which is the tooth, and then we click OK. Just need to wait a bit until CATIA finish creating all the 47 teeth. Alright, so after waiting for a while, we have finally successfully um, construct our helical gear. 47, 20, and 47 is the number of tools, and 20 is the width of our gear. Next, we can hide all the lines by using tool, hide all curves, tools, hide all points, so we can have our gear, total gear as we needed. Alright, now we can look at part body. So we have only this one, and this one. Okay, cool. We can change this view. So we have black lines there. Okay, now what we can do is we can start with firstly applying the material. So the material of the gear is of course steel. So click steel, click on part body, and then click OK. Right, now we can also change the color. Alternate enter, so we can change the graphic. So we can change the color to for example, I click on yellow. Right, so with this yellow instruction sheet, we need to create a flange here. So the size is 24, so 4 millimeter towards here. Before that, what's the size that we need to create? So we need to create a circle with the diameter of 42, and then extrude at 4. So we create first a sketch on this body, and select the origin, or O. Make sure that it is starting from the origin. So we have a center bore afterwards. We want to create a hole. This is the hole where we will use it to install the gear to the shaft, and the size is 42, and the pad is 4 millimeter. Right. Okay. Next, we need to create um, HVD or chamfer. So it's chamfer 245. Chamfer 245. Click OK. And then we need to create the hole over there. It's this shape, right? So we have created the um, flange of the gear, and then we need to create a keyhole on the surface. So we click on we select the surface, and then we click on sketch. So in here we can use this function, select the keyhole form, keyhole profile, and can start from the origin, and have the shape of our keyhole. Next, change dimension. So this should be 4 millimeter, and this is 12.5 millimeter. Next, what we need to do is 28.3, 25. So we need to create a line that connected this two, right? Then we need to trim the unwanted half circle here. Next, we need to measure this. So the dimension should be 28.3 from the instruction drawing, and started from the origin. Yep, and yeah, can exit the sketch. Now we need to um, create pocket by selecting the sketch as well, and um, we select up to next, click, click OK. We have the complete um, yeah, complete construction of our first helical gear of 4720. Right, so 47 is the number of tooth, 20 is the width of the gear. Right, with that we have finished the first gear, helical gear, and you can continue with the construction of the other 4 gears by just um, changing the dimension that we have created here, and by using the copy paste function you can also repeat the process for the other 3 type of gears, helical gears. And also remember, by looking at the instruction sheet, you have to also build this or construct the flange of each gear that is required for each different gears. Okay, that's all from me.